Now, I'm sorry, I forgot to record this problem, but let me just review again. So we went over this question. We started reviewing from this problem, and we looked at the graph, and we saw that the y-intercept was 2, and that means that the starting number, the first number is the starting amount, which means it's the y-intercept. So when you can look at the graph, you find where it crosses, that's your A, or your starting amount. And we looked at, we just reviewed if this number, which is called the common ratio, and that's if it's just a multiply number. If you have to use percents, we use this one. And we have growth and decay. So here we looked at this one as 0, 2, and then the next number was an 8. At 1, we looked and we saw it's an 8. And so when it goes from 2 to 8, we realize it's going times 4 every time. Now what happened is that this one then went down 1. So the asymptote is usually here at zeros, at y equals 0, so it did go down 1. Now this is the one that Frishta was having questions on, and these are just my notes from the video that I made. I think I made it yesterday. And let me see if I can make it bigger. No, here we go. Now, as we read the problem, Jeffrey is a spelunker. Now this is it's not a very common word. A lot of people don't know this word, but don't get stuck sometimes if you don't know a word. It just means that he's a cave explorer. So spelunkers are people who explore caves. He's been collecting data on the growth of stalactites, and in the cave, these are the stalactites. And so the trick on this one is that the 1 is missing. And so you have to figure out, well, if I go 2 to 8, that's times 4, but I need the in-between number. And so I just did times 2 times 2. Now, whenever you see the 0 here, you know this is your A. So I know it starts at 0.02 because it's across from the 0. And to figure out this common ratio, which is the 2, I have to find out what happened in the in-between. And so I just really guessed until I found that number. The first number I guess would be a 4, but that's too big. So I can either try a 3 or a 2. I mean, it might be some number in between, but when I tried it with the 2, it worked. So so we found the formula, which is starting at 0.02. I found the common ratio, which is 2, and that's the B. And then to predict for 10 years, then I put the 10 for the X, and to come up with this amount. But Frisha, you said you weren't sure how to use the calculator on this one?
Yes, Miss.
Well, I mean, I just started with 0.02, and the first part I did was, I'm just here at a menu. You know, when you work this calculator, you turn it on, and if you don't get the regular calculator, you go to menu 1, which is this first one. You can either push the number 1, or you can just make sure it's black here and then push the corner button to get, and if it's got writing on it, you just push all clear to make it clean.
Okay.
And then like 0.02, you know, times 4, well, I do get the next number, but I have to find out what's the middle number. And so then I tried times 2 again. And if I take the 0.02 times 2 and then multiply a second time, because I need to multiply by 2 twice to get to this one. I have to multiply once and then twice. And I just, you know, there's very few numbers to guess. Because you probably will start with a 4, because you see a 2 and an 8. And then you have to use a number smaller than 4. And then once I had the formula, then I just typed it in with the 10. And I'm going to need to use this key right here, which is the exponent button. Let me clear this out. 0.02, and then I'm using the parentheses. You can use the times, but I like to use the parentheses, raised to the 10, and then it will
20.48.
Yeah. But was there something different you were trying to do? Because I think you know how to do that. I've seen you do work like that one before. Was there something different you were trying to do? Or was it just that I put a 6 when it should be an 8? I wrote a 6, but it's an 8, 20.48. Was there some other question that you were having?
Yes, I got it. Another question is like this. It's the same, 25.
Yeah. So again, this is my notes from the video. So if you want to watch this again, it's on the under week 7. I think it's video for practice number 2. This is the practice number 2 video. Now that one's not all there, but so here, if I'm trying to find the numbers that are going down, and I see that the numbers, instead of going bigger, they're getting smaller. So I know it's decay because the numbers are getting smaller. Now to find the common ratio, or what's being multiplied, then I have to reverse the process and divide. So I did in the calculator 16 divided by 20, and that gave me the 0.8. So I just did 16 divided by 20 to get that number. Because I'm going up the table instead of down the table. And then I tested it, and every time I multiplied by 0.8, I kept getting this number. And so here's the formula. I know the starting, if they give you the 0, then you know the A from the table. Sometimes they start with 1 or some other number. But if they give you the 0, then you know what your A is. It's 20, and then 0.8, and then to the number of bounces. After the first bounce, after the second bounce, after the third bounce, and on down. So after the 7th bounce, it's going to give you 4.2 feet. The difference is that in the problem, they give you the B as a fraction instead of a decimal. But 4/5, I mean, I can just go 4 divided by 5 and see that fraction is the same.
Oh, yeah.
And so that one, and then I checked this here. I put this in the calculator with a 7 because it says on the 7th bounce. So this is after the first bounce, it's 16. After the second, you know, these are the numbers after each bounce. So let me clear this up. I start with 20, and then the common ratio is 0.8, and I'm going to raise it to the 7. Again, I'm just using this button, and then I'm going to use this button to say equals. Now this is 4.194304, but that's going to round to 4.2.
Yes.
Now, the other thing I wanted to talk about this one, because sometimes what they'll do is they'll talk about the percent of decay. And if this is 0.8, if the B is 0.8, what that means is there's 20% decay.
Okay.
Because we're going to start at 100, and then what do I subtract to get to the 80? And again, my brain converts decimals and percents really quickly. And so I have to remember to stop and explain that. 0.8, then you move the decimal 2 times. And when you move it 2 times, you're going to have to add the 0. So this represents 80% that's there. So what's going down is 20%. You have to find the difference to make it equal to 100. And so, and notice that this is going down. This is the B is less than 1. So it all kind of ties in together. Did you want to go over any of the rest of the problems, anybody?
This one is, I think, the H is correct, number H.
For this one, 26?
Yes, for 26.
Well, see, it's at the beginning, it's 256, and then on Tuesday, 192. Wednesday, there's 144. Which function describes best the problem situation? Well, it started at 256.
This question is ma'am decay.
Well, I can tell right now it's this one. So it starts at 256, and then let's see if this is 0.75. This says the common ratio is 0.75, and I can test that. Let me clear. 256 times 0.75, and I get 192 times 0.75, 144. So that's what's happening. It started this, and then every time it's multiplying by 0.75. So this is the one that matches.
Mm-hmm.
Let's go, maybe I'll just, represents the data. This one starts at 16.
Yeah, 16, 20,
This is close
25.
to 16.
C is correct.
Then 20, then 25, then 20, 25, and 20, and 25, 4, 5. Well, it's going to be one of these two. One is that I know this is discrete. This is discrete, which is dots. So I know it's not going to be this. It's not going to be one of these, because these are continuous. And this is just dot, dot, dot. And
Yes.
so 16, 20, 25, it looks like it's both these, but what I need to do is find the common ratio. And so I'm going to back it up. So I'm going to go backwards, and I'm going to go, what would I divide to find the ratio? If I want to find how it's being multiplied, what number can I find out how it's being multiplied? Well, if I'm going in this direction, it's multiply, but I don't know that number, then I'm going to reverse and divide. So to find that number, I'm going to back it up, and I'm going to go 20 divided by 16. So it's 1.25. So I see it starts at 16, and then every time it's going to multiply by 1.25. Well, let me double check to see if that works for the 20 to 25. So if I go, let me start with my beginning number, 16 times 1.25. Oops. And I'm going to keep going. This should be 25. So the next number would be about 30. So these two are still very, very close. Because how much is each square? On the y-axis, how much is one square?
That's 15. 10, 15.
No. 16.
Well, it takes two squares to get to 20. So one square is worth 10.
Yes.
This one is 16.
Mm-hmm.
So they're not giving us the starting number, really. They're giving the second number. This one is 20.
Yeah, this 20.
Now, in between, if one square is 10,
Yeah, another one is 25.
and this one is, well, this is 30. This looks like about 35. That
55.
may be too much. Really, what I'm looking for, the next number is more close to 30. So here, this one is 16. This one is at 20. This one is at 25. And then this one is really just a hair above 30. So
I made a mistake.
this one is just a little bit too high, but this one is better. Really, these 3 points on both of them are very the same. Where you have to really predict is what happens next. And so you have to take that next number and multiply with 1.25 to find what's the next number, and then find the next number. And this one's just a little bit too high because this line is 30. This is 40, so this is more like 35. And this one is closer to 30. Right there. It's more close to the 30 line. And that's when you have to be extra cautious and look at a lot of things. So that is a hard one. So this is a mural for art project. Pillars that decrease in height, so they're going down. The first pillar is 243. So that's my starting number. Each subsequent pillar decreases by a factor of 2/3, which represents the height of each pillar in terms of its position in the sequence of pillars. Now, really, I can make some quick choices without even doing a lot of calculations. Is this going to be linear or exponential? And then is it going to be continuous or discrete? So first, let's decide, is this going to decrease linear or exponential? Are we decreasing by subtracting? Are we decreasing by division or multiplication.
By divide.
So the first question, is it linear or is it exponential?
I think it's linear.
Well, this word right here tells us gives us the answer, really. Factors are numbers that get multiplied. And so it's either this one or this one. It's not linear because factor means multiply. Now it goes down because this number is less than 1. It's 2/3 is less than 1 whole. So factor tells me that it's being multiplied. Now, is it going to be continuous or discrete? So we're measuring the first column, or the first pillar is 243. Now to put that 2/3 in, I'm going to go ahead and keep it at the parentheses. But if you've not used this calculator much, you're going to use this ABC button. So I'm going to go 2 ABC 3. And that's what 2/3 look like, the fraction. It's got this little hook. It doesn't exactly look like a fraction here, but that's the calculator version. And so the next one is 162. And I can take my answer and multiply by 2/3. So I did the same thing. I did 2 ABC 3. And then the next height is 108. And what I'm getting is, I'm not getting the in-between numbers. So this is discrete data. I'm just getting the numbers 243, then 162, then 108, and I'm not getting all the in-between numbers. So this answer is 3. So again, the first decision is whether you're going to do linear or exponential. And the main way that I know that is because this says it's a factor. This would be if I was subtracting every time. Now, when you multiply by a number that's less than 1, it's like dividing. And here I'm multiplying with 2 and then dividing 3. But let's just think of this. B is less than 1, so the numbers are going to go down. So that's a tricky one. Let me pause to see what your questions are. Does this make sense, or is it confusing?
Yes, miss. Makes sense.
Everybody? You can be honest. You can use your reactions if you want. There's at the bottom. If it's kind of making you crazy, put the one with the tears or a thumbs up and say, I got it. We're ready to go do the last one on this one real quick. Okay, we've got a lawn care business and they've purchased a lawnmower for $6,500. Make this one bigger. It's expected to depreciate. What does depreciate mean?
It's opposite of appreciate.
Yeah. So is the value going to go up or down?
Down.
Down. And we're going to go down at a rate of 15%. Which function represents the value of the riding mower in dollars, which is VT? This is so the value in dollars over time as a function. So what's the starting amount?
6,500.
Okay. So right away I eliminate these two because these both have the starting amounts. Now what value goes in here? Is it 0.85 or 0.15?
0.85.
0.85.
Yeah, you've got to remember we're going to go 1 minus the 15%. And when you, so this is either where you go 1 plus R or 1 minus. So we're going to minus the rate or the percent, and that gives you the 0.85. Over time. Okay. There is, so let me get, that's that part. Let me come back. Hello, back. Do you, when I'm showing on the paper, do you see me off to the side, my face, or do you just see the paper?
No, we just see the paper.
I know if you up in the right corner is a little, if you put it on speaker, then maybe you can get a different view where you can get more, if you need to see my face while I'm explaining, if that helps. So let me just real quickly, I should have done this at the beginning, but let's see where we're at in our classroom. So we are down to the final. So we're in week 7, and there's only 8 weeks. So we've just got a few more days left in class, basically. So these were the, from yesterday, I have to click a little bit more to get to what you see. This is the GIM kit, and so Maria and Frishta, you said you got in and you were able to play some of these questions. So this is a good place to review. Oh, she got knocked out. So there should be lots of questions. You can still, that's, I think, some excellent study for the test. Let me get back. And what I was going to go through today was this assignment. It's a review, a test review. And let me just do some reviewing. We haven't done a lot of talking about the graphs. So let's talk a little bit more, because the first question here is about the domain of this function. Now, what can you tell me about that function right now? Can you tell me the starting amount? For number 1, what is the starting amount?
14.
Yeah, it starts at 14. And then can you tell me if this is growth or decay?
Decay.
Yeah, and why do we know it's decay?
It's lower, it's less than 1.
Yeah, the B. So which one is A?
14.
14. Which one is B?
The 0.8.
Yeah, so 0.8 is less than 1, so this one is decay. Now we got to look at the domain. So let's see if let me let me open it a different way so I can write on it. I think is the easiest way to do this. Give me a second here. I've got to save it so I can write all over it and not ruin my. Okay, I still can't get it into Cami. That's where I want to play with it. Okay, my apologies. I'm going to try something else. Thank you for your patience. You guys are awesome. And I'm sorry I'm doing this. I mean, this is no fun to look at, is it?
Hmm.
I'm getting there. I'm getting there. Okay. Come on, come on. Okay, went back too much. I have to make a copy. That's what I need. Okay, now here we go. We're in business. So this starts at 14, but do you see anything plus or minus after the X?
No.
So this one goes something like that. Oh wait, it's decay. Never mind. Let me go back. It is decay, so it's going to go the other way. This is a growth curve. So this one goes something like that. Now I made it down just a little bit too far. It doesn't go past here, but it's going to go here. So the domain is still like how far to the left and how far to the right. So what's the domain of a curve that goes something like that?
All real numbers.
Yep. Okay. Now this one is, now we're asking about the range. The range of a function. And this one starts at 120 and it multiplies by 7. Do you see after here any plus or minus?
No.
Let me see. I don't want to get this too messy, so I'm going to redraw this one. This is for number 2. So this one is one that's going to go something like this. Now, because there's nothing out here that says plus or minus, the asymptote is still at the x-axis. It's still right here. So let's think about what's the range. How far up does it go?
Forever.
Forever. And so where does it start?
And 0.
It starts at the 0. And then does it go up or does it go down? Does it go greater?
Down.
Less. It's going down. Oh, no, it's not. From that 0 point. So again, from this point,
Went forever.
from here,
Mhm.
we see it going up. And so that is greater.
Oh,
From here, from the 0, this is the 0 point, it's not going down. So this one is greater than or equal to 0. So think about number 3.
the range.
Let's do this one in red. So what
So
was
would
the
it? So would it be y is less than 0?
Well, here's the 0 on the y. Is it above there or below there?
Above.
It's above. So that one's above it, greater than 0. So when you see it above it, it's the greater than.
Mm.
Is that still playing with your brain a little bit, Gabriela?
Yeah, because the other one was the first. Oh, never mind.
Yeah, from the
I
0.
thought I thought we were using the graph for the first one for the second one. Never mind.
Well, yeah, this now is this. I basically erased the graph for the first one. I didn't leave it. So this is, it starts at a big number and then it's getting bigger.
Okay.
And this one's just going down. The main thing for the range is you want to look at the end. Do you see anything plus or minus there?
No.
No, no. If you don't see that, this is the range for all of these. It's gonna, we'll show one in a minute that's gonna be different. But so here's a question again about domain. So 6 and then going bigger is a curve that goes like that.
All real numbers.
Yeah. Now, how are you, Maria and Frishta? And I think Kimberly got back in the room. I feel like Gabriella's got it, but how about you guys?
Yes, I got it also, miss.
Okay, if you've got questions, speak up. This one is again about the range. And again, when you're doing the range, watch out for plus or minus at the end. It hardly ever happens. So the range is almost always this one right there. Is this one going to still be greater than 0?
Yes.
Yeah. Well, it's not saying what's the range. It says the range of the function is where y is greater than r for some value of r. Oh my goodness. So what is r? Y is greater than
The
some
rate.
number. So this is kind of about reading the algebra of it. So they're giving you this statement, y is greater than r, and then they want to know what number would you put here for r?
The 1.125.
So the range, let me switch colors. So the range of this one here, and again, the graph is gonna look pretty much like this. It's gonna start, and because this is growth, it's gonna go up to the right.
Mhm.
so that they all have this basic curve. You know, the details of where it sits on the graph might be different, but it's still the same curve. So what's the range?
All real numbers.
That's the domain. What's the range?
Oh,
So we're going to look at the XY graph. Oops. So it's here. What's this? What's the Y value right there?
0.
Y
Zero.
greater than 0.
Yeah. So when they're asking what's the R, it's going to be 0. Because the range is Y greater than 0. But the way they're asking the question is a little different. You know, they're saying the range is Y greater than some number. They're calling R. And so what is that number?
0.
0.
0.
So what could this story be about? What is a possible scenario for this situation? This one's a little so think about some of the stories we've told about putting money in a bank, or about a car depreciating, about stalagmites growing, about the height of a ball. What could be a story about these numbers? Let's say you have something.
Can we just use like the bank?
Yeah, let's make one about a banking. What if this was numbers and this was about something that happens in a bank? What would the story be about those numbers?
You have, I don't know. I guess like you start off with $725.
Yeah, and usually in a bank, let me put some bank, you deposit $725 in a bank account. So oops. Then what happens? What's the story there? So this is the starting amount. We got that in there. It ran away.
I have to go look at one of the stories.
Well, is this money growing, or is the amount of getting bigger or smaller?
It's growing.
And what rate?
Okay, so the one is by itself, but there's a rate of 0.125 or 125. Because wouldn't that be a percentage?
Yeah, what's the percentage? So we got to think about what percentage. So that earns some percent of money. So what percent? So we have to figure out which part of that is the percent.
125.
You're getting closer.
$12.5.
Okay, let me.
But don't you move the decimal to the right 2 times?
Yes.
1, 2, so 12.5.
So yeah, it's hard to see this, but see what we've got is this formula. So we have 725, and this is earning interest. So it's 1 plus some rate, and the rate part is 0.125. So I have to kind of take apart that percentage. I mean, take apart the 1, and that's here. And this part, the 0.125, is the percent. But just as Gabi said, what we're going to do, or Gabriela, sorry, we're going to move it 2 times to the right. And so this would be 12.5%. So it's, you know, it's something that's earning 12.5%. Well, that's a lot in a bank. Usually it's about 3 or 4% that they'll give you. But that's a possible scenario. But just to know, to take apart that here's the 725, and then here's the percent part. The 1 is part of the formula. We'll take a few minutes and look at these 2 or 3 problems. Or these, well, we'll just do 6 and 7. So just take a few minutes, think about your answer. You know, write them down on a piece of paper if you need to. So let's talk about this one, domain, for a minute. Or it says the domain, and there's a function it has 4 times 12 to the x, and then we're going to change it to 4 times 24 to the x. 4 times 12 to the x looks like this. I'm going to multiply by 12. 4 times 24 to the x looks like it just goes steeper. How does the domain change?
Wouldn't it stay the same?
Bingo. It's still forever, 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 forever. So the domain will not change. It hardly ever will change with an exponential function. Now, what about the range? I mean, yeah, the range of this function.
Y is less than.
Less than.
Yeah, because this one's going down.
Less than 0.
Now, it's still 0 because there's still nothing here, plus or minus. Is there one like that? No, I think that's the same one. Okay, I think I'm gonna do number 8, and then I'm gonna let you do the rest. How would the range of the function be affected if it were changed to negative? So this is positive 16. And this is negative 16. Now this is kind of a trickier one. So let's think about what would happen if you, what's the only thing difference between these two formulas?
There's a negative sign in front of it.
If we look at these two, the only thing different is that this one has a negative and this one doesn't. So let's just, yeah, I'm going to use the pink here. So 16 and then goes down. So it starts as a 16 and it goes down. And let's look at where let me kind of, and it would go something like this, probably this one. Now it's starting at 16, so it's probably somewhere around here. Like this is 16, that's the y-intercept, and then it's going down from there. Now, what do you know would happen? The only thing that would be different if I put the negative in front of it.
Will the reflect still follow with this?
Yeah, if we're gonna look at this one, I'll put this one, it's just gonna be a reflection. So this one will come up like this. It's just, I don't know if you can see my hand. It's gonna, on the top, it's gonna flip down to the bottom.
So would it still remain the same? The y is greater than or equal to 0?
So this one on the top, the positive one, is greater than or equal to 0, because here's my 0 line, and it's above that. So what would the range be for the blue one?
Y is less than?
Y is less than 0.
Yeah.
Okay, I see.
So which letter is that?
D.
D.
Yeah. Yeah. So that should get you a start on this review page. You know, there's a number of questions there. You want to think here, like what's happening to get to that, find the missing number. It's the same idea here. You may have, we haven't quite talked about this in terms here and here. Do your best with those two. Let me see how you do, give your best guess on those. But everything else should be kind of exactly what we're doing. This is a good review. The GIM kit is good. Let me go back to, today is Thursday. I would really like to give you more time to say, you know, finish this one today and be able to contact me if you have questions and get some help tomorrow. But tomorrow, I'll put some kind of a question on there. Here's what I'm thinking with the GIM kit. The GIM kit, I really like it in some ways, but it's not functioning the way I would like it, which means it's not really telling me who's playing the game. And Frishta, you said you played the game, but it didn't save your money, your points?
Yeah. Yes, miss.
Yeah,
Well,
I played it yesterday too, and it told me like if I exit, it's not gonna save my stuff.
yeah, I don't know what's happening there, but I do think they're excellent problems to play with, and it is a very good way. So you just give me a comment through the assignment that you've done it and you've played it. And I would say there's time again on Friday to play some more. What I would rather do, you know, what I think is the best plan is to say tomorrow is still a study day and that Monday is the test day. And then we're gonna just kind of review everything a little bit. And then we're gonna have a very simple kind of final review activity for next week. Maybe not, I mean, yeah, simple-ish. It may sound simple to me, but but we'll practice. Basically, a lot of the test is going to be what we're doing right now, but I may start to put some review activities on Monday as well. But we'll say tomorrow is a review day, and you know, I know I have a lot of meetings, but I will respond as quickly as I can to any questions. I'll definitely be responding when I can over the weekend. I'm very, very excited. I'm almost gonna cry, is that I get to see my dad this weekend.
Oh, so good.
I got my,
It will be nice.
yes. I have seen him through the phone. My sisters go to see him, but I'm getting all teary. I got the negative test, and where he lives, they don't allow, they're just now allowing some people to go see it. So I got my test results from COVID. I got a negative test, which means I get to go see him. So I'm super, super excited. So, but otherwise, keep texting me if you have questions, and I'll do my best to answer them. But part of the time I'm going to be in Houston visiting my dad.
Oh, so good, Miss. I
Yes.
didn't see my father almost 5 years.
Oh,
Me too.
Yeah.
it's those, they're precious times, very special times. So
I'm really happy, ma'am, to see your father.
yes, thank you. So you guys have, you know, I don't want you to feel like you're alone, but we're basically, this is the review, and you're studying for the test, and then the test will be Monday. I'll post it on Monday.
Okay, Miss. This review is all for today or tomorrow?
Yes, this is, you can finish today or tomorrow.
Okay, thank you, Miss.
Yes,
thank
thank you.